My name is Jeff Barr, and I'm here from Amazon.com in Seattle. I want to give you a perspective on some of the things that we've done at Amazon to use some of the, not just open source software so much, but open source philosophies in our business, and show you how we've used those things, how they've worked for us, and also talk quite a bit about one of the bigger initiatives we have underway at Amazon, the Web Services Initiative, where we're essentially kind of ripping the covers off of the company and making a lot of our internal systems, technologies, business models, databases directly accessible to software developers. All these things have worked really well for us, and this is actually the first time I've gotten a chance to talk about more of the opening up as a philosophical kind of a model. I'm usually a bit more focused on the nuts and bolts part of the web services effort. And so this is a great opportunity for me. I appreciate the invitation, and this is my first time in Honolulu, hopefully not my last. So here's my ground rules for my presentation. Please ask lots of questions. I really love to interact with my audience. If there's something I say that's unclear, if you want to know a bit more about what we're up to, please just stop and ask me. Please interrupt. Please feel free to take anything I've told you today, put it on your blog, tell your friends. I'll be here for the rest of the day, so any one-on-one discussion would be happy to talk with you. Let me start with just a little bit of background, who I am, and I've been doing software development since about the late 1970s, I think, was the first time I got actually paid to write any code. I spent time at several different startups and situations like CTO or temporary VP of engineering. I spent some time at Microsoft. I was on the Visual Basic 6 team as a senior developer. I was on the Visual Studio.net team as well. After that, I kind of got tired of the slow pace of life at Microsoft. Was actually looking for something really fast-paced, and Microsoft really wasn't it. It was kind of country club compared to what I was hoping for. Spent a few years consulting. Was really lucky. I got to work with some aspiring venture capitalists, and one of the neat things that they were looking at back in 2000, 2001 was the very new field of web services. So a lot of the projects that they would put me in were let's go look at a new technology. Let's see what these guys are up to. If they funded the company, they would put me in as the CTO or the VP of engineering, and I helped get these companies off the ground. And a lot of what I would do there, I'd go out and help them to raise more money. I'd go out and make a lot of presentations. A lot of these companies were in the web services space, but at that point, 2000, 2001, web services was more of a concept than something that was really grounded in reality. So I'd give these presentations, and I'd have some nice kind of boxes on the presentation, but there'd be this kind of big cloud in the middle of, don't worry, in the future there'll be all these really cool companies with web services, and if you just kind of trust us enough, these web service things will actually exist. People will use them, and so we were trying to actually sell web services tools, and for the most part, everybody looked at us as, yeah, right, this just doesn't sound like a very plausible future at all. But I had a lot of faith in the web services concept. I'd done a little bit of that at Microsoft before leaving. And so finally in about, it was early, mid-2002, I saw the first beta announcement of the Amazon Web Services program. Saw that, and it was really a great thing for me to see, because all of the kind of cloudy, indeterminate, kind of futuristic things I talked about in my consulting career were actually like reality at Amazon. I saw that Amazon was really putting public APIs onto their internal business processes. They were opening up, they were inviting software developers to write applications against their APIs, and kind of the future all of a sudden became the present. And I just said, I really, really want to be a part of what Amazon is doing. I was based in Seattle, they were based in Seattle. My consulting career had been kind of hampered by the fact that 9/11 made travel a whole lot more difficult. I'd been commuting back and forth to Silicon Valley, and what used to be a one-day round trip if you got up early enough and got home late enough, turned into basically a 3-day trip. And that got to be just not nearly as much fun anymore. So I joined Amazon in kind of, when was it? It was late 2002 as a senior developer working on the Amazon Associates team. At that point, there were about 6 people working on web services. They had a position opening as an evangelist, but I wasn't quite sure what the evangelist was all about. Didn't feel qualified coming in from outside the company to be the web services evangelist. At the same time, there was nobody else doing the job. So they said, okay, why don't you do 5 or 10% of your time as the evangelist, and we'll just kind of see how it goes. That 5 or 10% of my time quickly grew into about 100% of my time. So before too long, they said, well, you're effectively doing the job of the web services evangelist. Let's just kind of do a quote interview for you to hire you for that position. I made that transition in early 2003, and since then it's been my job to go out and talk to user groups, conferences, developers about what we're up to with web services, and basically invite developers to look at what we've done, get a good understanding of what it's all about, and then build tools, build applications, build all kinds of interesting sites around the Amazon Web Services. So now I'm officially part of the Web Services Developer Relations team. The web services effort at Amazon has grown substantially since those early days when there were just 6 developers. We're now in the multiple hundreds of developers simply building web services, combination of different kinds of things that we do. Partly we're taking existing internal processes, putting friendly wrappers around those, exposing those to the outside world. And in the other case, we're building whole new services from scratch. Sometimes we build them so that they're useful both to Amazon internally and then also to the outside world. My open source credentials, I've been a Linux user since late 1994. I had a fairly good job at a startup. I was VP of engineering, got a bit bored there, and got an opportunity to take some earlier work I'd done and port it to Linux, which in 1994 was a fairly kind of new system. I didn't really have any experience using it. I'd plenty of Unix experience. So on the strength of what I'd heard about it and what I'd read about it, and what its future looked like, I actually quit my steady job. My wife was pregnant with our 5th kid at the time. And I said, whatever, I'm sure I can make this Linux thing work. I took a 500,000 line application, got it ported to Linux, and was pretty impressed by what it was all about. So I've been a Linux user ever since. In my spare time, I've been building a site called syndicate.com that's an RSS feed directory, runs on multiple Linux servers. I've got about 80,000 lines of PHP. I've got a MySQL database with 90 tables and about 300 gigs worth of data in there. I've been an Emacs user since I think about 1980 or 81. So I've been using open source. I don't contribute a whole lot back. I find that when I'm building things, it's too attractive and too interesting to get a little bit distracted into actually going and fixing the tools you work on. Like if I'm using PHP, if I find a bug in there, sometimes I'll look at that bug, I'll figure out what's wrong. Occasionally I'll submit a patch back, but it would be way too easy to get involved in the actual development process, and I'm trying to stay focused on my job and on my personal projects rather than finding another fun thing to do. So has anybody not heard of Amazon.com? Cool. You'd be surprised. You'd be surprised. You've never heard of us. Well, you're from Australia, right? Okay. You have the internet over there? Yes. So you'd be surprised, actually. Not everybody has heard of us. So we are best known as an online retailer. We have over 52 million active customer accounts, meaning people that have logged in and actually made a purchase from us in the last 12 months. We have website presences in 7 different countries: the US, UK, Germany, Japan, France, Canada, and China. Not quite as well known as that we're a great technology consumer. We have all these great websites. We have a data warehouse that's among like the top 5 or top 10 in the world as far as amount of data in that data warehouse. We have a world-class logistics system. When you place an order with us, we can, in a matter of a fraction of a second, figure out the most efficient way to ship your order, whether it comes from one distribution center or multiple distribution centers. We optimize to make the customer experience as quick as possible so you get things when we promised it to you, but also to keep our costs as low as possible. We're also not very well known as a technology provider. However, there are hundreds of thousands of Amazon associates. The associates use our affiliate system to take data from our site. They take data from our catalog using our web services. They take that data, they put it on their own sites. Maybe they have a blog and they want to have a little column on that side that says, these are the books I've read, this is the music I'm listening to. Or they can build their own vertical site. They could build a site that's just about open source programming or Java programming or books about Hawaii. They can take that data that we give them through our web services, put it up on their own site, and then they can earn commissions between 4 and 10% based on the traffic and the sales that they send to us. If you've ever made a purchase on Amazon, you've probably seen our marketplace program where you see when you're on a particular detail page, it shows you that in addition to the Amazon pricing, that there's other sellers that have listed their products on Amazon. Those are called marketplace sellers. There's over 1 million active marketplace sellers who either have a hobby or a full-fledged business listing and selling products on Amazon. And then finally, we have over 140,000 software developers that build applications using our web services. So my main goal as I go out and I speak to different groups is to get people to know about web services and get them to register as software developers so we can keep that number healthy and growing every day. So let's talk about what opening up means to us. When I think about this, there's really two different aspects to it. The first is bringing in new things, making the company receptive to things built outside. And then on the other side, giving things out, taking things that we've built inside, data we've collected, making that as open and as accessible as possible to outsiders. Aspects of bringing it in, using open source principles, accepting user contributions and data on our website, using various kinds of open source software, using open data formats where it makes sense. On the giving it outside, those same user contributions, user data that we've collected, we want to make those out and available both on the website and as aspects of our service. The whole Amazon Web Services program is all about giving out data. And then finally, as we build various kinds of software building blocks, some of which I'll talk to you about today, we want to make those as open and as accessible as possible for developers to build around them. What are the different open source principles that we use at Amazon? Releasing early and releasing often, definitely a very important principle for us. We put new services out in beta. We like to get them out there at a kind of a medium stage of development so that we're able to get feedback from early developers. We like to upgrade them as quickly as possible. We find that if need be, we can go from complaints about a particular service or a suggestion or something we need to change. We can go, let's say that starts at the beginning of a week. We can go from day one, here's a change we need to make, to within a matter of often less than a week. We can get from idea all the way out to implementation on the site. So we're able to do that, release early, release often. We can listen to our community. We can respond very quickly. One of the really frustrating things at Microsoft was the fact that, we could listen. We didn't have any great vehicle set up to listen, but we couldn't respond. It would take years and years and years to actually get a new release out the door. By that time, whatever person had given you complaints was probably moved on to their next thing. There was no way to actually get this good sense you were closing the loop, that you saw issues out in the field, you understood what they were, you knew what it was, what it would take to change your system, get those changes, get them out to users. We can do that whole cycle inside of a week at Amazon, which is it's remarkable. It's very, very satisfying. Once you get into the point where you have that great feedback loop, you've got the input coming in from your developers, you've got your internal development teams primed and ready to go so that when new input comes in, they can quickly look at it and say, okay, we know what to do, we know how to address that, we're going to get that built, we're going to get it tested, we're going to get it out the door in a matter of a week. It's one of the most satisfying ways to actually work in the software business. We build on the success of others. We do a lot to learn about what others are doing, both with open technologies, and with web services. A lot of ways that we trust the users. And in the kind of classical software company, there's like the developers inside that company kind of put themselves up on a pedestal and decide, we know what's best. We're the kings effectively. We're going to make all the decisions. Those little peon users out there, we're going to happily take their money, but we're not going to actually respect a whole lot what they have to say. We find that our users have just great input. We love to listen to them. We love to just get as many different emails and blog postings, discussion board posts as possible. It just gives us so much feedback on what it is that we're doing right and also what we're not doing right. Giving those users a voice, super important to us. Every different way that we have open to us, we listen to our users. They send us emails, they complain about on our discussion board. We created a developer advisory council where we invite about 20 developers in to meet with us every quarter, sit them down, brief them on what we're doing, and then we just say, okay, tell us what you're up to. Tell us what has worked, tell us what's not working, tell us where we need to change. And then also sharing about what we've learned. As I go out, I talk to different groups, love to share all the successes, give them ideas for how the other companies could put their own web services into play, and give them hints as far as what they need to do with services, what they need to do with developer relations, how they go out and do technology evangelism. We're more than happy to share all those kinds of things that we've learned. Let's take a look at how we actually bring things into the company. I took just a quick look at our website, found a lot of different ways that we accept data from users. We take ratings, so if you see any item on Amazon, you can log in. You can then give us a star rating from 0 up to 5 stars in increments of half a star. And I've got lots and lots of screenshots of the Amazon site here, as you can see. Can't get all the details, but you can see the star rating here, customer reviews. We allow our user community to actually take pictures of the products and submit them to us. There's a quick review process to make sure nothing unseemly slips into the system. And we're able to have users do more as far as adding pictures to the site than we're able to do ourselves. Generally, we'll take each book, we'll get a picture of the cover, we'll scale it up to 3 different sizes, we'll put it on the site, but we ask users to give us more pictures of the products. We say, give us pictures of you using the products, give us pictures of these products actually in kind of in situ, in the situation you use them in. If it's a stereo component, show us what it looks like as part of the rest of your stereo, show us how those appliances look in your kitchen. We ask users to write reviews. We have reviewers that have written hundreds and hundreds and hundreds of reviews on the site. You give people the mechanism, they're more than happy to share their knowledge, their opinions, their concerns, the good and bad points of the products. In this particular book I chose, let's see, there were on the order of several hundred reviews entered. I think there were 170 reviews entered just for this one book.
Is there any moderation of those reviews at all?
Yes, there is. What happens is that there's a way that a web viewer can flag a review as somehow inappropriate. So we generally do require that users be logged in and that we know who they are before they can enter reviews. So we don't have the anonymous effect of, say, /dot, where just a bunch of random people go in and just post garbage. Question there?
So, just one question. How can we dispose of reviews of early editions of books when the book has been substantially reviewed?
So generally, each different edition of a book will have its individual identifier called an ASIN. So I believe that the reviews are particular to an ASIN rather than spanning across all the different editions of a book. So edition 1, 2, and 3 should have individual identifiers. And my understanding is that each of those would have separate review collections associated with them. It doesn't look like that's the case.
My 2 books, second edition came out in August last year, and the reviews for the first edition are still up there as for the second edition.
Interesting. We should talk offline. You should show me those, and I'll see what I can do to get those. I know there's also room for the author themselves to put input into the site. So you can put like an author's review in there. And we did that explicitly because in the past we had some authors go and they'd create their own accounts and names under other names and put in spurious reviews. So we've made it really explicit now for the author to say, I am the author and I've got something to say about my book.
Could that include response to other reviewers, point by point kind of thing?
It certainly could. We also allow the users to vote on the utility of the reviews themselves. So at the bottom of each review, there's a link that says, was this review useful to you? Yes or no? And we basically use those as a kind of rough indicator of what order we should place the reviews in. So if some really reviews are very informative, they'll tend to bubble up toward the top of the list and vice versa. If people read it and it's clearly just a flame job or a hack job on that product, it'll slowly sink down toward the bottom of the list. Okay, other ways we take input. So let's see, recommendations of people who looked at this, also looked in other products. That's direct input from the website. So click behavior and search behavior is aggregated and then used to let us give better navigation options across the site. Similarities, any kind of patterns that we see. We allow users to tag items so they can put little mnemonic information on there. You can see the tags kind of down here. It's been tagged with things like gift or award or impressed or future purchase. Various kinds of lists. So as a logged in Amazon user, you can create your own lists of things you'd like to buy in the future, an Amazon wish list. You can create lists called List Mania lists. You can create baby registries, wedding registries, gift registries. If you want to kind of put yourself out as an expert in a category area, you can write what's called a So You'd Like To guide. So if you want to learn about a particular topic area, you can write a guide about learning about Linux networking or how to do PHP development. Your guide is a combination of text and then pointers to other Amazon products. Something new that we're still experimenting with, discussion on the site. So we actually have a discussion forum associated with each product. So you can go in and just on this particular book, there's a whole discussion going on about this book and what people thought, kind of what it inspired them to do. And this is actually one of those things you might think, who's going to go in and start chatting about one book? But just on this one book, it looks like there's 3 separate discussions and 10 different postings on there. They are. So there's actually 3 separate subjects happening just on the course of this one particular book. And then finally, if none of those other ways of input work, suggestions. So we have just free-form text there. We have things that if there's information that's missing or wrong, or something wrong with the page, or there's bad content, we allow our users just to go out and directly tell us. They don't have to hunt down, oh, where's that Amazon customer service number? How do I email them? How do I contact them? We just go in and we just blatantly just solicit all this input right there on the site. Let's take a look at the different kind of open source tools and applications that we use at Amazon. All of our servers are Linux-based. Don't even know to an order of magnitude how many servers we have. I've heard 10, 50, 100,000 servers, something in that range. I don't have any way to verify that, but I've heard numbers like that bandied about. Apache web server, lots of developers using Emacs and GCC. HTML Mason is a website production tool. Not only do we use it, but I believe the author of that tool now works at Amazon. Lots and lots of Perl code. When I first started, I had to kind of dust off my Perl books and write a bunch of Perl code for my first couple assignments. Some brand new use of PHP. Traditionally, our database has been a lot of Oracle, but there's some very big projects, very successful projects now using MySQL. We use a combination of CVS and another tool called Perforce for source code control. Now, we also do contribute back to these. I don't have an exhaustive list that says, these are all the things we gave back to the community. We do that. We tend to do it very quietly. There's a number of interesting issues as a big company you face when you start making contributions back. It turns out that we do make a lot of contributions. We don't keep like a master list and go out kind of making a big deal about it. These are the standards that we actually use, all the way down from HTTP and HTML and CSS. The whole web service effort is built around things like XML and SOAP and XSLT for transforming data. We use standards like the XML schema and the WSDL files for describing web services. So now we've got all that data, how do we actually give it back out? We expose the reviews on the site, we expose the ratings, we give out wish lists, list mania lists, all the pictures, purchase circles that we actually aggregate locations and companies where purchases has been made and say, people in this state or in this city or that work for this company, here's some interesting purchase patterns we've observed in that particular area. And it's really interesting to look at, like, people that work at Microsoft always buy books about Microsoft. Kind of interesting. They're kind of in the middle of this big mystery, and they're saying, I need to learn a bit more about my own company, so they'll go off and buy books about it. And then just gobs and gobs and gobs of product data. If you load up a detail page and scroll through it, you'll see that there's tons and tons of neat information on there. For books, we'll give out things like product, the size, how heavy is the book, how wide, how tall, how deep is it. Every last bit of data that we can possibly come up with, we're able to give out. Both on the web page and then in web service form. So essentially everything you see on a particular detail page for a single product is also available through our ECS, our e-commerce service, which is the service that exposes our product catalog. Okay, now the web services model we call AWS, or Amazon Web Services. So much as the website is the retail/consumer interface to Amazon, AWS, the Amazon Web Services, is the developer interface. So this is a set of APIs, application programming interfaces, that give developers outside the company access to our data and our technology. Lots and lots of different kinds of services, as I'll go into. Things like product information, all the customer-created content, the reviews, the wish lists, the ratings, the shopping cart, so applications can build their own shopping experience, keeping the user on the site as they navigate through that outside site, put things in a shopping cart, and only at the point when the user says, I'm ready to check out, do they transition from the outside site, maybe you'll build your own site with Linux books on there, transition from that site over to Amazon. At that point, we log in the user, take that anonymous shopping cart they've loaded up, and push that into their own private shopping cart. Access to our data warehouse. We've been working with an Amazon subsidiary company called Alexa. They have 300 terabytes of data, of web crawl data. We're working with them to create a service called AWIS, the Alexa Web Information Service. All that data is open and available. If you need to do searches against it, if you want to explore web connectivity, we have this service to give that out. And finally, the newest category is something that I'm calling building block services, fundamental data structures, fundamental, essentially horizontal services that should be useful in a wide variety of applications. One of those is called the Amazon Mechanical Turk. We just rolled out in November. Unique, totally different from anything you've ever seen Amazon or any other company do. I'll show you quite a bit about that, what it's being used for. Hopefully open your minds a bit to start thinking about other ways it can be used as well. These are some of the things that categorize or characterize, actually, the web services concept. To me, it's all about building a programmable website. We support the right industry standards, XML, XSLT, SOAP, we use WSDL files, we use schema files. By doing that, we're pulling off the web front end. We're giving outside developers direct access to the data and the functionality inside of our site. We decouple the data and the presentation. We hand out the raw data to developers. Those developers can then take that data, they can style it, format it, structure it, organize it any way that they would like. Because we're giving out all this data, we're unlocking developer creativity. If a developer wants to build an online store, they can focus on the fun stuff. They can get product data, they can put it on their site, they can let Amazon do all the hard parts. We can have the multiple hundreds of millions of dollars of warehouses. We can deal with shipping, with logistics, with credit card purchasing, with bank accounts, with customer service. All those nitty-gritty things it takes to run a real business, we can do those things, let you, the developer, focus on the fun stuff. Getting a great concept, figuring out your business model, putting it online. By having all these services, we create a platform to attract developers. As we roll out service after service after service, we're starting to see applications that use not just one Amazon service, but sometimes even 2 or 3 different services put together. And then this also gives us a great way to leverage our technology investment. We invest on the order of hundreds of millions of dollars per year in the Amazon technology platform. We get great use of it from our 7 different sites, but it's wonderful to see other developers are able to make use of it as well. So instead of 7 sites, we have 7,000 different sites that are using the same data, the same technology, the same infrastructure. This is our product family so far. This is a great slide because every time I do a presentation, I have to revise it because we're rolling out new services at a rapid pace. A year ago, I only had the Simple Queue service and the e-commerce service. In the last 12 months, we've rolled out 4 new services. We've got the Mechanical Turk. Basically, this is something we call artificial intelligence, and I'll tell you a whole lot more about what that means in a little bit. It lets organizations with work to be done tap into an internet-scale workforce, and they can put simple tasks into the system. You can invite people all over the world to do this work, and they get, of course, paid for doing that work, all mediated through the Mechanical Turk website. We have the Amazon Historical Pricing, or AHP. We've exposed our data warehouse directly to developers. So if you're, let's say, an Amazon Marketplace Marketplace seller, and you have inventory of particular books, or you're thinking about going into business in a particular product category, you can use the historical pricing to get pricing trends from us. If you want to know, do these particular books sell better in the first quarter, the second quarter? Do they do best at holiday times? Is the average pricing for these products, does it seem to be kind of on the rise? Is it on the fall? The historical pricing service gives direct access into that multi-terabyte data warehouse with all that information buried inside. The Simple Queue service is an application building block. Lets you build a simple data structure called a queue, essentially a first in, first out data structure. People generally build those within the space of a single application or a single network system. With the Simple Queue service, you can have one queue within your Amazon account that can be shared by applications running all across the world. Great as a data sharing mechanism, as a coordinating system. You can have things like data collection where you're collecting data up from any number of different places, posting that data into a queue, having one collector aggregating application, pulling data off the other end of that queue. This is a neat building block in that it's used by outside developers, but also other Amazon services use the queue as a storage, as a coordination mechanism.
Is that queuing primarily like messages?
Right, so each account can have up to 4,000 queues associated with it. Each of those queues, we're still in beta with this, but each queue can have up to 4,000 items inside, and each item can actually be up to, I think, 1 megabyte of data, and it's just raw data that you put into it. So whatever you put in is just going to march through the queue and then come out the other side untransformed, unexamined by Amazon.
Is there some transaction commit rollback?
It's totally transactional, so that if you build an application, you have very strong guarantees as far as what you put in will emerge on the other side. Now, because there's a distributed implementation, there's a few interesting little subtleties as far as sometimes you can get data twice under certain conditions, but we do give people exact programming instructions as how to make sure that you don't process the same thing twice. It's a highly redundant, highly scalable queue. Any piece of data is probably stored in 3, 4, 5 different Amazon data centers around the world. On the second column, the Alexa Web Information System is that access to that 300 terabyte data warehouse. You can do searches across that. You can examine connectivity. One real home for this is in what's called SEO, or search engine optimization. If you're doing any kind of affiliate marketing, one of the things you need to do is you need to get your site as popular as possible in all the search engines. So using AWS, you can do a direct query and say, who's linking to me? What is the quality of all those sites linking to me? You can get traffic statistics, traffic rankings, direct access through all those APIs. If that level of searching isn't good enough, the next level up is something brand new we rolled out called the Alexa Web Search Platform. This has been called Roll Your Own Search Engine. What we've done is we've put several hundred very powerful servers online. We've given developers the access to not just get to that original 300 terabytes of data, but they can build their own applications that run in our data center to mine that data. So you build a core of an application that knows how to process a single page at a time. You define from this huge collection of 10 billion web pages which ones you'd like to process. And then you turn this loose, and it'll parallelize your application automatically, run it across any subset of that 10 billion web page collection that you'd like. And then finally, the original, the grandfather of all these other services, ECS, or the e-commerce service. This is complete access to our product catalog. So one thing I don't have on this slide is the fact that we do have a business model for each of these different services. We tried really hard not to do what I would call the science experiment model of web services, where you simply put out a lot of services, but it's not really clear exactly what the reasoning is behind it. It's not clear how you make money. It's not clear how users use it to make money. We tried very hard to make sure that there was a legitimate, robust business model attached to each of these different things. In some cases, that means that we simply charge for access to the service. We charge either a monthly fee in the case of historical pricing, where for several $100s per month, there's essentially unlimited access to the data. In others, like the Simple Queue service, it's transactional, where you pay us a certain amount per item that you put into or remove from the queue. Alexa Web Service, it's call-based, where each call you get 10,000 calls per month for free, and then you pay 15 cents per 1,000 calls after that. The Alexa Web Service platform, you pay based on computing power, on memory, on bandwidth. Mechanical Turk, you pay us a commission based on the work that you put into the system. And then ECS is available for free because the business model associated with that is really simple. The more data we give out from the system, the more websites it shows up on outside of Amazon, the more traffic, the more clicks, the more purchases are going to come back to us. In fact, if you take the ECS data, you build your own site with it, you will ultimately get paid for using that, because if your site is at all popular, you're going to get sales through that site. You can earn 4 to 10% commission on that site. People use that all the way up from, I'm going to put up my blog and I want to just kind of pay my hosting costs for my blog, all the way up to organizations that are 4 or 5, 10 people even. Their only business is to build ECS-powered sites, get them very popular, drive traffic to them, and earn substantial amounts of money by doing so. So if you're going to go into the web service business yourself, make sure you're not doing a science experiment service. Make sure that there's a reason for you to be giving out the service, a good business value that you're getting back, and make sure that there's a reason for people to use it. Some of our competition, some of the other kind of big players in the web services space have rolled out some interesting things, but with no clear business model as far as will they charge, why are they doing it, what's the point other than the fact that they get a lot of attention when they roll it out. So we found when we put out web services that it was really important not to simply roll out some APIs and some tattered bits of documentation and say, okay, figure out the rest. We found that there's a whole lot of things you need to do to have a very, very rich, very complete offering. For example, we put both parallel APIs for SOAP and REST are the two main protocols for getting to web services. there was a lot of disagreement in the web services community 4 years ago as far as which is the best way to do it. We found the best thing to do was simply put both of those up side by side, let developers make a choice of what worked best for them in their application. REST is a very, very simple model that instead of using all the extra layers of SOAP, you simply present a URL to a server. There's parameters in that URL that say, for example, I want to search this catalog, this is my key, these are some other customizations, and then that server simply responds with a big block of XML to you. So you kind of obviate the need for all the other layers of the SOAP stack. Very, very easy, very approachable kind of programming model. I think I have a slide in the next slide or two that show a bit of the REST model as well. It's different and simpler than either one. One of the great things about REST is you can actually prototype it in your browser. You don't need really any programming tools at all to get started. You simply put that URL in the browser, you customize it a bit with whatever search terms you want. The XML comes back, and the developer part of your brain looks at it and says, well, I know how to do HTTP GETs. That's really easy. And I know how to look at that XML. I can either process it as a string, I can use a parser, I can do regular expressions on it. Whatever kind of level you'd like to approach that block of XML as, it works with REST. So in the web services world, you describe your various services with a WSDL file, web services definition language. We have those for each service. We describe the raw XML you get back from REST using schema files. Very, very extensive documentation. We put it out in 3 different forms. We put it out in online HTML form, PDFs, and CHM files for Windows developers. For the ECS service alone, there's over 500 pages of documentation. We do a lot to encourage our community. We have a developer bulletin board, hundreds and hundreds of posts per week, lots of activity. The funny thing about bulletin boards, you go in and most of what you read is like negative. And so if you're kind of coming in from the outside, you'll say, wow, this thing must really suck. Look at all these people complaining about it. But nobody just hardly ever says, wow, Amazon, great service, thanks a bunch. So you only see the friction points. That's the really interesting thing. But I've noticed most bulletin boards are like that. But newbies kind of get into our bulletin board and say, wow, that service is really bad. Look at all these people complaining about it. But they're only complaining because they're trying to do really hard things with it quite often. We found that we have to set a very friendly tone on the bulletin board. It's interesting to look in various bulletin boards in various communities. You can see friction sometimes between the vendor, the proprietor, and the community. You can see that can just grow to just absurd levels of just distrust and negativity sometimes. So we try really hard to get our developers to like us, not just by kind of slapping them down, but by listening to them and saying, okay, we're trying really hard here. This isn't easy stuff. We're doing our best to provide you with a great service. Very occasionally, some new person will kind of stop in and just say all kinds of just unusual things that just don't fit with the tone of the board. The great thing about our community is the community themselves will step in and kind of moderate that person and say, you don't have any sense of history of what Amazon's been doing here. You don't understand what the past was like. You don't quite understand all the complications. So our community really is on our side, by and large. There's a few folks that are always just kind of our critics that are always whatever we do going to attack us for it. But by and large, our community has been wonderful to us. We've had folks that went in and tried to do essentially some tricky things or ways to exploit kind of loopholes in our system. And they get this bright idea and they'd post to the board and say, hey, I get this great idea. We can rip off Amazon by doing such and such. And we don't even need to go in and do anything about those people. The community jumps in and the community will just rally around each other and say, don't you dare do that. We do not want you to wreck this kind of this great thing Amazon's up to. If you cause them to shut it down or to restrict it in any way, we're going to find you and we're going to retaliate against you. So the community is very protective of each other and very receptive to new people coming in, as long as they kind of get it. So I love our community. Whenever I travel, I do my best to actually find folks that are in the community and get to meet with them. When I go to Silicon Valley, I can quite often find some developers there to meet with. We also send out newsletters to keep them informed. We have a blog at aws.typepad.com. I write the blog. I've done like over 200 entries in less than a year for that blog. Talk about new applications, new versions of our services, a little bit about our conference schedules, just all the different things that we think developers would need to know to do a better job of building apps with our services. Who's using all this stuff? 140,000 developers out there building applications. Now, like any community, you sign up a lot of developers, and not every last one is going to actually go out and build a world-changing application right away. Generally, with these kinds of communities, you see somewhere between about 10 and 30% of the developers are really actively building things. Amazon associates are sending traffic to us. Marketplace sellers listing and selling things online. Our larger merchant partners, companies like Nordstrom's and Target and The Gap, are using services to get their products into our catalog. Integrators and solution providers often work with the merchant partners to help them get their sites integrated and get their data into us. And then lots of entrepreneurs that look at the various services that we have, look at the business models, and then get that great idea and say, okay, that's kind of the missing link for what I'd like to do. I'll use Amazon as my fulfillment partner. I'll use their associates model as my business model. And we love to see all the creative things that people come up with. One of the newest ones I saw is called smarkets.net. And what it is, it's actually a stock market. It's an imaginary stock market, or a predictive market, as some people are calling it. And the deal with smarkets.net, you actually get to buy and sell shares in Amazon products using a virtual $10,000 they give you. So what you do, you go to the site, you create your account, you log in, and then you buy shares and products based on your best guess as to will these products rise or decrease in popularity over time. So if you know that like a new book has come out and you expect it to become more popular, you can buy 100 shares in that book and watch it day by day as it goes up. If you see something that's currently popular but you believe will decrease, you can short it and you can make money as its sales rank goes down. Not something would ever have thought to do. It's actually very, very infectious. I found myself going back to that site like 10 times a day to check how I'm doing, learning interesting trading strategies. Like you can always take something ranked number 1 is kind of an obvious way to make money, because you can always take that one and you can short it, and for sure it has to go down from number 1 at some point. So lots and lots of fun things that people build. And I've got some screenshots of other kind of neat creative things. And these guys are always pushing the boundaries of not just of what can be done, but of our thinking of what can be done as well. You know, a lot of times you'll get an idea and you'll say, well, I don't think that could be done. And you kind of like optimize it away in your head. And you never actually quite get to the point of doing it. We see people that take these supposedly impossible things, they just go out and do them, and they just email me a URL, or they come up to me at a conference, hand me a card, and on the back of the card this URL say, hey, look at this cool little thing I built in my spare time. And you look and say, wow, didn't ever, either I didn't think it could be done, or never thought anybody would have an idea that unique and that far out. So I'm always happy to see neat new things that people come up with. Just a tiny bit for you about architecture. At the bottom, we've got a technology platform, lots and lots of servers all running Linux, Oracle databases, MySQL databases, code in a variety of languages, lots of Perl, some C++, some PHP, some Java on some new things. One of the fun things about Amazon is that each development team gets to choose what languages, what technologies work for them. And the great thing is that once they make those choices, they build their systems, they don't just take those systems, kind of throw them over the wall to some operations group and then lose track of them. The big surprise when you join Amazon as a developer, you get there, you get your orientation in the morning, you meet your boss, he hands you a pager. It's like, what's this for? He's like, well, you know, once the development team builds something, the development team also has to keep it running and support it. So you're going to be on pager duty in 2 weeks. You need to know how everything works. So teams very quickly learn how to build things that are scalable, that are robust, and that don't break at 3 o'clock in the morning. It's one of those really kind of surprising, shocking things. Like developers always like to be a bit abstract and kind of build things and then let somebody else do all the dirty work. But at Amazon, the development teams themselves get to do all that dirty work, and they need to keep them up and running. So if you build something and it does break at 3 o'clock every morning, the next week when you're off of pager duty, you're going to pull that code up and say, okay, I did something wrong here. I need to make sure that this doesn't break the next time. So on top of that technology platform, we've built our 7 different international websites. We then have a big body of shared code for all of our different web services: request authentication, error checking, metering, billing, accounting, parsing, XML generation. Then atop that, just month after month, we're just throwing out new services. This is another great slide, because every time I do a new round of presentations, I get to evolve the slide a bit and squish even more into that pink layer up there. This is the e-commerce service. It's in its 4th major release. Complete access to the Amazon product catalog, millions upon millions of products. I don't actually have a good count of the number of products we have in our catalog because there's a lot of different ways to count them. And every time we count them and put out a number, some Wall Street analyst looks at it and says, that doesn't actually make sense. I counted them this other way, and you don't have that many. So we just find it's easier just to say millions and millions of products. A very rich data schema. If you make one inquiry to ECS for one book, we're going to give you probably close to 100,000 bytes worth of XML in return. Product description, pricing, 3 different sizes of images, reviews. If it's music, we'll give you a list of all the music tracks. We'll tell you sales rank. We'll tell you the weight. We'll tell you the size. Every last detail that you might think is in our catalog probably is in that catalog, and we do as best as we can to give it all out through web services. Very occasionally there's one little bit of something that we don't have. It either means we didn't get around to it, and in a few cases we simply don't have the rights to give out various kinds of things. There's a lot of data in the catalog we acquire from other places, and some of it we do have permission to give out through web services. Others we still have to actually go out and seek that permission. But by and large, if you see it on a detail page for a product, it's almost certainly available in our web service. Product images, 3 different sizes, reviews, access to the shopping cart, so you can create a shopping cart object, add items to the shopping cart, initiate the checkout process. We do actually insist that the checkout process run totally on the Amazon site. We're not wanting to encourage any kind of tools or applications that would encourage users to use their Amazon usernames and passwords anywhere else but on our site. You can imagine with all the various phishing attacks you see going around that it's a real bad idea to get people used to the idea that any site could claim to be Amazon when it really isn't. So we always insist that the actual checkout procedure of entering a name, entering a password, selecting shipping information, credit card information, final checkout approval, all those things we want to happen on an Amazon site, not on any third-party site. Detailed access to wish lists, and then the all-important link to the Amazon Associates program for a business model. Different kinds of functionality, searching the catalog, getting detailed information about individual items, doing a similarity search. You can pass us one ASIN pointing to one product and say, based on other user viewing, purchasing, clicking behavior, what other products are similar or related to this particular item that I've passed in? You can do customer content lookup. You can say, what are all the reviews written by this person? Now, as a quick word about security here, we made it really, we were very careful with security. We've got an excellent record for never doing the wrong thing security-wise. Didn't want to jeopardize that, of course, with web services. So there's nothing you can get through any of our APIs you wouldn't be able to get if you were a non-logged in, anonymous user hitting our site with a browser that wouldn't even accept any cookies. So whatever you see on our site, that's the range of what you can get out through web services. That's really a really important point to make. Operations on the shopping cart, creating it, modifying it, adding things, getting the shopping cart contents, finding sellers, finding all the listings entered by sellers, finding wish lists, pushing data into wish lists, all open through various kinds of APIs. Let me show you a few different kinds of sites that have been built by various developers. tvmojo.com. Wonderful thing about this, developer started out building a few sites for himself in his spare time, built a nice PHP script to automate the process of designing a site, getting the colors, getting the labels, getting the products in there, selecting all the categories you see there on the left. He took that script, put a nice UI on the front of it, started giving away a copy for free, and then selling a professional version for $99, turned this into a great side business for himself. He's able to give away the free version because he came up with a really neat business model for it. When you get the free version, you take that free version, you configure your store, you configure your associate ID in there, but the code also has his ID in there as well. So what happens is that 9 out of 10 times when this code switches over to Amazon, it's going to put your ID in there. So you as the user of this free script get 90% of the profits from the site. Justin, the developer of this script, he gets 10% for himself. He gives you that script for free in exchange for getting 10% of your business. So very creative model. He can give something away for free, but then participate in the upside that's generated from that script. I actually use this script to build my own site. I have a site called developer-books.com. From loading the script onto my server to getting it designed and online was a matter of about half an hour. So if you have a great idea for a site, you can do it very, very quickly, very easily.
Does this also show you the status of the order and show you all those things
So we have not yet exposed order status APIs. There's some kind of privacy security issues with doing that. It's something we definitely want to do in the future once I think the right web service standards are in place. We're looking at things like messaging technologies and RSS feeds that we might be able to directly give data back out to the user to say this is where your product is. Because one of the things that people love is they place the order, they get their tracking number from DHL or FedEx or UPS, and they love to actually say, okay, where is it? You know, what is it? It left the building, it's in the distribution center, it's en route, it's getting close, it's getting closer. And I know there's even been some neat hacks. It'll take your shipping number and then graph that on like a Google map or Yahoo map. So you can actually almost see the package getting closer and closer to you. So we have found that there's a certain set of our customer base that they're kind of obsessed with their shipments. And it turns out that every shipment goes through about 42 different status levels as it goes through the whole Amazon system. Now, we wouldn't want to send anybody 42 emails as it transitioned from state to state to state in the system. But if we could expose that as some kind of event distribution or an RSS feed, people might find that interesting and just kind of micro-track their products. Definitely something we're looking at for the future. Okay, this is one from a company called the Hive Group. It's called the Honeycomb. This is a way to actually look at an entire Amazon product category all at once on a single screen. Written in the form of a Java applet. When you start this up, it starts on a particular product category. And I wish I could show this to you live because it's very dynamic. All the controls around the outside are dynamic restrictions on how much information is shown. So you can see we've got these multi-ended sliders here. We can control hard drive capacity or CPU speed or installed RAM. As we adjust these things, the actual graph in the center will dynamically change to match. Each of those little boxes represents a single product in the catalog. If we were to put the cursor over one of them, we'll get a pop-up that describes the product in more detail. In this case, it's set up so that the size of the box represents price. We could represent the rating, the number of reviews, number of different things. We can select individual manufacturers, CPU types. If I just wanted things with an AMD processor in there, I could do that. So this is a very unique, very creative way to show our product catalog. Another unique way to do it, this one called Live Plasma. This one's great for music searching. You can search for an individual band. It'll put that band in the center, and then it'll link that band to related bands, influences, other kind of similar bands. Uses a number of different data elements and algorithms to give a very rich, very dynamic presentation. We can click on any one of these to move it to the center and kind of reiterate the query with that band as the center point. Great for finding popular bands. There's also people that love to find the most obscure bands possible. So they'll do a query like this and look at this poor little unconnected band here and say, who's this? I need to know the guys kind of hiding in the corners here.
This technology, the relatedness diagram and so forth, is that something that's part of Amazon itself that exposed as an API, or is this?
So in general, yes. So we expose what are called similarities. So whenever we return to you a product, we also give you similar products. We give you artist information so you can say, oh, here's all the things by this particular artist. Now, in this particular case, there's connectivity, there's sizes, there's colors, and there's two really essentially enigmatic Frenchmen behind this. And no matter how many times I've asked them exactly what does it all mean, they'll just say, well, we have a number of algorithms and lots of data. And they won't actually tell me all exactly what's happening inside here. It's very predictable. It's totally consistent. It's not picking things at random. But they don't want to really give away the details of exactly what's happening in there. My guess is that they have a lot of data from Amazon. They're probably blending in some other data sources as well. With that, right, yeah. Mm-hmm. So these are the kinds of things I've shown you. Probably wouldn't see them on the Amazon site. Great ways for developers to exercise their creativity. These guys built this neat multi-visualization technology. Next thing they knew, they actually had to deal with CNET, where the same bubble technology you can see on CNET in their news, one of their news sites, there's a little kind of corner there where it shows a number of different kind of maps and relatedness indicators for news stories. Pretty cool thing to be able to do. Started working a couple months ago with this guy who calls himself Crazy Dad. And this guy is a professor of visual arts at a university in California. And every week he basically builds some other really totally wacky, very creative thing. I saw some of the other things he'd done, and emailed him with information about Amazon and said, you should give our APIs a try. I think you could do some neat stuff. He emailed back and said, yeah, sure, I'll take a look at those in a couple weeks. A couple days later, he started emailing me all these URLs, said, I looked at it, it's really neat. I built a lot of different things with it already. So here he built, on one page, he took our cover art, and he's got 900 different cult movies on DVD, all on the same page. If this was live, I could put my cursor over it and get a detailed pop-up. Once he got this going, he just kind of went crazy. He did cult movies. He did shoes. He calls this the Imelda Marcos collection. You can see there's kind of a, he used there's kind of a shoe as a meta picture there. Or 500 gifts for geeks. 500 different Amazon products on there. 1,001 scary reads. I'm not sure what the big picture is supposed to be. Is that like a pumpkin, or what does that look like in there? Never been quite able to figure that one out. Perhaps. Or 1,001 art books from Amazon. We got the eye there. Very, very cool stuff. Just, I love to see these kinds of things. Some of them are bestsellers. Others are because they had some level of creativity they wanted to exercise, and our data was the perfect way to be able to do that. Here's the S-Market site I was telling you about, the buy stock in iPods or Da Vinci codes. Love this concept. I just found out about this one last week. I've got one of my boys introduced into it. He's got an account. He's having good fun with it. Buy stock in Amazon products and simply watch them rise and fall. Turns out that kind of buy and hold investing isn't a good idea for products. It's very, very volatile. You make your investments, you see it go up 10 or 20% in a day, sell it right there and take your profits is the way that seems to work very well on this. But I can't quite tell you this is going to sell 1 million. I don't know that's going to make a lot of money for him. He had some great ideas and decided this was the thing he'd like to do with those ideas. Good stuff. No. It's virtual money. Virtual money. So this is my account. I actually bought, I sold short some sales of the iPod Nano, and I have a profit there. And some other things haven't quite done as well for me. But lots of fun and just interesting to see the rapid fluctuation of things in the catalog. Let's move on to the next service, the Alexa Web Information Service. So we have a not so well-known subsidiary called Alexa. One of the things that they do is every quarter they do a web crawl. And in that web crawl, they download 100 terabytes of data. They somehow pick the 10 billion most interesting web pages. I'm not quite sure what metric they use, but they've been doing this for a while. So they pick 10 billion, they download them, and we've now opened up that data through the Alexa Web Info Service to outside developers. You can search through the crawl, you can get URL info about what's the speed rating for this, how many people point to it, how many things does it point to. You can use that to do things like building a web map, build kind of a graph of connectivity of the web, kind of detect hotspots. Very, very neat stuff, and there are a lot of users of this. I don't have good examples to show you on this, only because a lot of the people doing this are doing some kind of very competitive web data mining kinds of operations. They're doing great things. We can see by the bills that we're sending to them and by the amount of traffic. There's a lot of stuff happening here, but generally we go and say, hey, what's it up to? What are you guys up to? They're like, well, it's just working really well for us. It's about as detailed as they want to get sometimes.
Why is that done only on a quarterly basis? Does it take that long?
I think that's actually what it takes as far as CPU power and storage and bandwidth to download 100 terabytes. So they always keep the current crawl and then 2 historic crawls. Now they also, if you've ever seen the Alexa toolbar that runs inside of Internet Explorer, the Alexa toolbar also sends some information back to the service that, with the permission of the user, as it sees pages that have changed, those newer pages will be kind of incrementally recrawled. So it can be newer than a quarter, but it's kind of guaranteed that it'll be at least 1 quarter old. So that's a cool service for us, relatively new. You can see that high-class data setting they've got there with racks and concrete floors and wooden ceilings. I think they've gotten better since then. Now, the Alexa web search platform, we just introduced this in, when was it? Late December, actually. Concept here is build your own search engine. Alexa's dedicated on the order of several hundred very powerful servers to this. And the idea is you can write your own data mining applications that run on those servers that can actually dig through that crawl and do your own customized algorithms, your own customized data processing across that. So there's 3 steps you have to take. First, you use a little rules engine, and you figure out within that 300 terabytes what set of pages you want to access. So maybe you only want to access JPEG images or things that are XML files or any kind of data you can either do geographically or by file name, by file type, whole different sets of rules you can use to specify a data set. Once you do that, you write essentially the inner loop, the innermost part of a loop across all that data. You only write the inside piece. You test it in a little testing environment before you turn it loose, because you might turn this thing loose and it's going to eat up, hundreds of hours of CPU time and lots of memory and lots of bandwidth. So you test it first. Once you're sure that your algorithm works on a small set of pages, you put in your payment information. You run it, you make a reservation for all the CPU time that you'll need. You run it on 1 to several hundred CPUs to get as much speed as possible. And then this will generate a data set. You can either take that data set, leave it on an Alexa server where there's a storage charge. You can expose it out as an XML feed, or you can actually publish it again as one more web service, adding into our web service collection. Brand new concept. We rolled it out very quietly in December. One thing that we've learned in the past couple months, and this is an interesting learning, you'd think that we've been online for a long time, that we kind of understand about these things, but what we've learned is you can't do quiet betas of anything anymore. You don't get to quietly announce things and have like a miniature scale for a beta and think, okay, we've got the beta period to optimize it and to scale up and to be really ready for the whole world to assault it. If you do something really cool and the right bloggers see it and they start writing about it, you will go from nobody knew about it and it didn't exist to the whole world knows about it and the whole world wants in. That can happen in 48 hours. It's utterly amazing how quickly information spreads now. Good information, bad information, it spreads around the world in literally at light speed. Yes, it does. So when we rolled this out, the plan was, well, let's announce it, and we'll get maybe 100 or so applications, and we'll pick like the top 30 or so, and we'll kind of hand nurture those folks through the beta process, make sure that we're good to go. So we rolled it out, and a couple people started blogging, and some more people started blogging, and we got like 2,000 requests for we'd like to be beta testers, and out of 30 slots that we could actually fill, it was like you suddenly say, we got this real winner on our hands. We got to do everything we can to service those first 30 people and the next couple thousand afterward. Pretty neat concept. So people look at this and say, I could actually compete with Google or Yahoo in some special vertical domain now at $2,000, $3,000 a pop to just do a search across some data structure. I don't need to build a whole data center. I don't need to invent my own web crawl from scratch. I simply use Alexa infrastructure and pay for it as I go. So it looks like it's going to be a real winner for us. Great pricing. The pricing model they came up with after lots of deliberation, everything costs $1. So for $1, you can get 50 gigabytes worth of data processing. You can get 1 CPU hour on a processor. You can allow 1 gigabyte of data to be downloaded after you've done all the processing, or you can service 4,000 web service requests. And we've got all the payment infrastructure, all the metering, all the billing. So once you're using this actually will just show up in a special part of our developer portal. It'll show you individual line items for all the services that you use during the month. And then we've already got your payment information, your credit card, and you'll just get billed at the end of the month, like any other kind of, like your cable TV or your phone bill. You'll get billed for the usage you make of these various services. So a lot of the infrastructure work we've been doing over the last couple of years has been, let's get all that billing and all that payment infrastructure into place so that we can then use it in a variety of different ways for services like this.
I don't get the 50 gigabytes of data processing.
I believe that refers to data that's transferred from the archive into your application. So the archive is a total, let's say you're using the most recent data set, so there's 100 terabytes there. You might pick some subset of that that's 100 gigabytes, so that it would then cost you $2 to get that data from the archive into your application.
Yeah, where it resides and services these web.
That's right. Well, no, actually you go from the archive into your own application processing. So maybe you want to, a good example might be, you want to process every JPEG image in the archive, and you want to make a list of every one of them that's of a certain size. So maybe you want to find every JPEG image that's 100 by 100 pixels. So you would, as your first step, you'd say, I want to process all JPEG images. You'd write your own application, would then go open up the JPEG, look at the header, check the sizes. If it was 100 by 100, write it out to the result set, otherwise skip it. So once you've got that built, you could then run that. You could specify, run this on 50 servers at a time, and then very quickly you'd have that list of all the 100 by 100 JPEGs in the archive.
You'd have a list, but you'd actually be copying the JPEGs as well.
Well, you would actually probably just copy the URLs, is what you would do. So the URLs would be a piece of result data. You could choose to store that data on the Alexa server. You could choose to make it an XML feed and either keep it to yourself, or you could give it out to either for free and you'd still be responsible for the pricing, or you could sell it to other folks. You could say, I'm in the image data mining business, and you could say, pay me $50, and you've just done $20 worth of processing, and you can say, I have a custom list of all the JPEG images that are this size or with these characteristics in there. So we're really looking forward to just all different kinds of neat applications that come up from this. People just got started on the beta probably in like the very beginning of January. I think the first beta stuff started going out. So a little bit of time before things will start showing up, but not that much time. People move really fast these days. Really, really fast. Okay, now let's go to the most wacky of our services here. All right, this is called the Amazon Mechanical Turk. The idea here is we're allowing organizations to take advantage of an internet scale workforce where these workers can do piecemeal work very, very economically. You go to mturk.com, you find pieces of work as a worker, you find them, you qualify to do the work, you submit that work, the work is returned to the requesting organization, they can do quality checking on it, and then they release payment back to you. Now the history of this is really interesting. I just finished reading the book on the plane over here. Way back in the 1700s, an inventor built a chess-playing robot that was called the Mechanical Turk. And it showed up, it looked like this. It was this big cabinet, there was a chessboard on top. And to all outside appearances, it played a really, really good game of chess. And it was exhibited all across Europe, it came to the US for a while, was unfortunately destroyed in a fire in the early 1900s. But nobody really figured out for quite a while what was really happening. When the original inventor would show this, he'd open up all these different doors, he would put a candle through, and people would look inside, and there were levers and gears and cables and all kinds of fun stuff. And even back then, people were like a bit suspicious. Like it played a very good game of chess. People were smart enough to figure out something's not quite right here. So people were always trying to catch him and figure out what's really going on here. Well, ultimately, what it turned out to be that through very, very, how did it work? There were all these little compartments inside, and there was this kind of sliding chair. And he would open like one door, and the guy inside would kind of move over to the other side. And then he'd close that door and open up the next, and the guy would move over to the other side. He'd open up both doors, the guy would be kind of laying down underneath this false floor. Actually fooled a lot of people for quite a while. Fascinating history. The idea here, though, was on the outside it looked like a machine. On the inside, there was actually a person doing the work. So Jeff Bezos, our CEO, thought that was a really cool idea. Turned out that concept has a lot of relevance for different things that both Amazon and other companies would like to do. So here's what we were thinking. Go ahead.
No, I was thinking as an editor, I often talk about, I run the OSTG editorial /com and all that, and the joke is always tell people what my real job is to set it up as a machine, so that you, as a management, don't have to think about it. Just, you spit in money, budget, and outcome pages on the web, and then you sell ads on those pages. And so I have created essentially that, an editorial. I call it our editorial machine.
So these are some of the things that we found interesting as we were designing this. We realized that humans are still better than computers at a whole lot of different kinds of things. Hundreds of millions of dollars have been invested, for example, in image processing and image recognition, where you want to look at some images and say, is there a dog in this picture or not? And the computer sits there and grinds and grinds and grinds away for a long time, and then gives you a result that might be good, might not be good. Whereas you can ask the average 6-year-old, is there a dog in this picture or not? And they'll be able to tell you, yep, there is or there isn't. So we said, what if the computer could actually ask the human to do a particular task and then give back the result? And then what if the computer can coordinate a portion of these tasks out to lots and lots of people and coordinate all the work of start with the work, find the qualified workers, get them to do the work, quality check it, get it back to the original requester. So we came up with this thing that we call the Mechanical Turk, that's an API that lets applications and computers integrate this artificial intelligence, which is really people underneath, into all kinds of new applications. So the Mechanical Turk is a web service that lets developers programmatically incorporate human intelligence into their systems. We see this as allowing businesses, entrepreneurs to do thousands, hundreds of thousands, millions of different tasks that need human intelligence. And to do it without having to go out and find those people, hire them, train them, get desks for them. You simply let people use their own equipment, use their own time, any skill level. We have a qualification system so that you don't get unqualified workers. I was at a conference earlier this week in Las Vegas, talked to people doing things like phone books, where if you run a phone book, you get people submitting data to you, text, pictures. You need to do some level of human verification. Are these good pictures? Did they spell everything properly? Is it grammatically complete? They get these things by the millions every year, and rather than using their own staff to do it, they're thinking about using the Mechanical Turk as their quality control agent. Another company I talked to, they do voicemail, and right now you get the voicemail as emailed audio files. He said we could use the Mechanical Turk to actually do transcription. We send out audio files to qualified workers. They do transcription to text and then send it back, and we take that and return that as a text transcription of a voicemail. So we're working with all different kinds of organizations right now to get applications built for the Mechanical Turk. One of those is called A9.com's BlockView. So A9 is another Amazon subsidiary. These guys have been doing something very cool. They're building different kinds of search engine technology. One of the things they want to do is have pictures of cities at the city street level. So they've been sending these trucks across to a whole bunch of different cities. On top of the truck is a camera. Inside the truck is a laptop, a whole bunch of storage, and a GPS. They drive down the block, and at every address they stop, they take a picture. So they end up with these long strips, look something like this, that they call BlockView. And at any given point, they're not quite sure what is the best picture to represent a business or an address. So they could have written a bunch of algorithms, they could have done a bunch of processing, they could have hired 1,000 people to do all this work. Didn't seem like the right thing to do, because they had a big burst of work, and then after that, they'd be pretty much done with given cities, time to do something else. So in part, the Mechanical Turk was built to help with this problem. We load up these BlockView images into the system. So once the right picture has been taken, so of all that strip I just showed you, you can see there was one picture actually had the McDonald's in there. So when we get the right picture, we can show it in the A9.com yellow pages that are actually hosted within Amazon.com. If you've never seen the A9.com yellow pages, it's actually very cool. You can go to an address on a block. You can then walk up and down the block, but navigating image by image, address by address on the block. So in order to actually do all this processing, they used the Mechanical Turk. We created these things called HITs, or Human Intelligence Tasks. And let me see if I've actually got a picture of it. Okay, so you go to mturk.com, you register as a worker to do work. You then see this catalog of different kinds of work that can be done. Now, the vision that we have for this is that a couple years from now, there'll probably be 2,000 different kinds of work in this system. Right now, we probably have about, on any given day, between about 10 and 15 different kinds of work, both Amazon work and third-party work right now. So that worker finds this kind of work, the BlockView work, and this is what they see. They'll see this web page with a number of different images on there, and I scaled it down quite a bit to fit it. I don't have a screen that wide. I did a lot of cutting and pasting to get that image to actually fit. So you see this image here, and the assignment that you get as the worker is to look at all these pictures and say, which one has this business? In this case, it's called the Tariq Khamisa Foundation. So the worker looks through all these, finds the best one. There's a little radio button next to the best image. They click it, they hit submit, and they earn 3 cents for doing that piece of work. So it doesn't sound like a whole lot, but the workers are very smart. They were able to very quickly optimize their processing. We had people that used big screen monitors. They were using Firefox plus GreaseMonkey. They wrote GreaseMonkey scripts to optimize this. So workers can actually do these BlockView hits at the rate of several thousand per day. We saw some people earning $20, $30, $40 per hour doing this. One very enterprising person actually hooked up a video game controller to their PC. So they were able to just sit there, kind of sit back, put their feet up on the desk, and just use the video game controller to very quickly, very easily pick out the right image. They actually got so efficient that they kind of outstripped our ability to take new pictures. So they drained the system very, very fast. This was another example of something that we rolled out kind of quietly. The intent was we rolled it out on it was like a Wednesday afternoon. We rolled it out in November. Rolled it out. We put it on the site. We put the site up. We did no blogging about it. We didn't talk about it. We did no press release. I was watching Technorati, which is a great way to watch for emerging trends. I'm watching Technorati.com, searching for Mechanical Turk. First hour or two, it's empty. Second hour, there's a couple mentions. And suddenly we're in this exponential growth where it's 4 and then 8 and then 16 mentions. And we're watching the traffic to the site. We're watching these hits just disappear as quickly as we can pull them in. And we're thinking, this thing's going to be pretty popular. And the next morning we wake up and it's on the front cover of Slashdot. Thank you very much. And we're on the front cover of Slashdot. And we'd scaled up for a beta. We were thinking, this will be, we'll put in, I don't know how many servers, but enough to do a good-sized beta. Certainly not ready for the whole world to jump in at us all at once. And it was a really interesting couple of days as we just dealt with all this traffic. And when you put the beta out, sometimes there's still some server optimization, some network optimization, some database optimization. I think we went through about 6 months of planned things to do in the space of the first 2 or 3 days we had this online. Learned a whole lot about just various ways that people are going to use the system. We had people try to game the system by kind of randomly picking images, figured out ways to detect that. There is a very complete scoring system in place so that if users consistently do very, very poorly at these different assignments, that we can detect that and they can actually be prevented from doing work in the future. We've got the whole payment infrastructure in place so people can do the work and then get paid. Been fascinating to watch the last couple of months as different ideas, different applications come up for this. Here's a picture of the workflow, what actually happens. We've got the mturk.com website in the center. On the right, we have any organization with work to be done. We call those requesters. So they use some web service APIs, push some work into the system. The workers log in. They find interesting kinds of work. They do the work, put the answers back in. The requester has been polling, making some web service calls to get answers about what's been finished, gets those answers back, does any kind of verification or checking. Now, one of the interesting kinds of verification that we have available is what's called plurality, where what you do as a requester, you put the same piece of work into the system more than once. Maybe you put any given work in there 3 times or 5 times, and you let the worker community ultimately vote on this. So if you put image matching in there, as soon as you see 3 people out of 5 have picked the same image, you say, okay, that clearly must be the right answer. We'll pay the people that got the right answer. The ones that gave us the wrong answer, we will not pay. And so you get that's how one of the ways you do quality control is by putting the same piece of work in front of more than one person. In other situations, we've seen hits that were things like French translation. So what those kinds of folks did, they would they'd put in English text, and the hit would be return the French text for this. And to do quality control, they would actually take the returned French text and put it out as another kind of hit and say, please verify that this French matches this English. So, and then we'd also make sure that the same people didn't see the same work twice, so they couldn't approve their own translations. So people are being very creative again with this, which we just love. We love to see totally interesting, totally surprising, and useful things for this. We see that it's going to take a couple years, but we'd expect this is going to get wired into different kinds of businesses, different kinds of business processes, really, really changing the way that large-scale tasks can be performed. So the requester approves the work and then releases payment to the workers. Let's take a look at the terminology. A hit, the human intelligence task, is the piece of work to be done. The requester is the company making the request that says, please match these images, please translate this text, please listen to this audio and turn it into a text file transcript. The worker, someone doing the work. And then a qualification is a test or a rule that is used to make sure that only qualified workers can do particular kinds of hits. The hit, the human intelligence task, is the work to be done. Currently, it must be loaded into the system with a web service call. We do anticipate at some point we'll have more of a end-user friendly front end. So for certain kinds of hits, you can just go on the site, design the form, design the inputs, and put those in directly. Right now, you do need to be a developer to get those hits into the system. It has to be a very discrete, very well-defined task. You get to build an HTML user interface using a meta language to specify the work to be done, and then protected by qualifications. If you need the user to be able to read French or to speak Spanish or to recognize images, you use these qualifications to put a little test in front of them before they can actually have access to any of your hits. The requester is the individual or the organization that has the work. So they design the work, they specify the qualifications, they put sufficient funds in their Amazon account to pay the workers for the given number of hits, and then they load those hits and the qualifications into the Turk. As soon as that happens, the worker community will find these pieces of work and will go off and start doing them. The requester, meantime, is polling the system, waiting for answers to come back, get those answers, validating them, releasing payment, and retrieving the results. One of the funniest kind of hits we've seen so far, one of the guys on our floor at Amazon had been growing a beard for a while. And he actually just for fun said, okay, I wonder what the Mechanical Turk worker community thinks. Should I have the beard or not? So he put in a really simple hit, and I wish I had a screenshot, but I don't. The hit was simply, with beard, without beard, which one do you like better? And he'd only paid a penny for this. So my expectation was that he'd get pretty much a 50-50 distribution, because who's going to bother to think for even a second for a penny? He actually got like a 1/3, 2/3 distribution. That 2/3 of the audience said he should have the beard, it was just one of these just totally wacky things. You say, okay, lots of kind of fun things we could do with this. That for not a whole lot of money, you can do essentially like a little consumer survey, a little opinion poll, a little kind of fact check very quickly on, put this in front of a bunch of people, see what they think. So.
What category would they find that work?
So the categorization is totally entered by the requester. So they get to put in some labels or tags with the work. So we didn't design any kind of like a full.
Give us your opinion.
That's right. The workers register with Amazon. We need to know their real identity. We need to know their bank account information. They find interesting hits. They do those hits, and then they get paid. They either get paid through Amazon gift certificate, or they can do a wire transfer into their bank account as well.
Do you do withholding?
Yes, we do. We spent a long time going through all the tax implications and legal implications of this. The way it actually works is that we're just the market. We're facilitating the connection of the requester and the worker. So the requester is actually, I believe, the legal employer. We're just connecting them up, is what happens. So we make our money on this by charging 10%. So if you're the requester, if you put in $1,000 of work, you will pay us an additional $100 as our fee for using the Mechanical Turk. So the last piece of vocabulary, real important, the qualification. The qualification is a quiz that you put in front of the workers to allow them to do a class of hits. They can either be multiple choice, and the computer can do the grading automatically, or they can be subjective, where you just give them free text input. So if you're saying the qualification is read this piece of English and render it back to me in French, you probably have to do a subjective grading. So in that case, the requesting organization gets all the answers back. They can then use APIs to either assign or not assign qualifications to the potential workers. And then any particular hit can have up to 10 qualifications assigned to it. Here are some of the more interesting hits that we've seen so far. At Amazon, we've used the A9 block view that I showed you. We've done confirm artist name, where the task is to look at an album cover and then actually extract from there the name of the performing artist that wrote that performed on the album. Extracting a product description, where you read a long text product description, we need a shorter summary written, or we need some bullet items written to describe it. And then the last one is really kind of interesting. So with Japanese text, you can either write Japanese text left to right or top to bottom. And a human can look at that in a second, and if you can read Japanese, you can apparently tell which way it goes. But a machine cannot do it very well. So as part of the work that we're doing to scan books, we needed to know, is this text going vertically or horizontally? So the easiest way to do it was not to do it algorithmically. It was simply put a page of text in front of the user, and then after they've qualified to read Japanese, just say, does it go like this or does it go like this? So instead of all that processing and all these algorithms that are going to be imperfect anyway, easiest thing to do is simply ask the user. We're working with tons and tons of companies on the outside to get neat kinds of work into the system. One of them that I love is called podcast transcription. I'll show you a couple screenshots of this in a little bit. You basically upload a podcast file, pick which episodes you'd like to get transcribed. They take the MP3 file for each of those episodes, farm it out in 30-second chunks to a number of workers. The workers listen to it. They enter in a text transcription. And then all those transcriptions are assembled and deduped and quality controlled, and the return result is an actual text file representing all the audio you hear on the podcast. We've seen language translation, both English to French and French to English, website review, where you have to look at a website and answer some questions about it, and running a marketing survey. You can actually go to dryrunner.com. You can design your survey, you put payment information, and they will then do all the work of getting that survey into Mechanical Turk and getting the answers back from there. Here's a walkthrough of this site that does podcast translation. This is a couple of developers that work for Los Alamos National Labs, so they built this site as a fun side project. It's called castingwords.com. We start here, and they offer podcast transcription services. We start by, in this URL box, we enter in the URL of our podcast. And what they do is they charge 42 cents per minute for this work. So I enter in the URL, and I hit the submit button. Their site then takes that URL, parses out all the individual podcasts that are in there, and it shows me the length in minutes. I select the ones I'd like, so I select just this one here. Hit the submit button again. It tells me it's going to cost me $16.38 to do that transcription. Looks good to me, so I hit the Buy Now button. Go to PayPal, enter my payment information. I pay them their $16.38. At that point, I'm returned to the site. Behind the scenes, the site's going to take that audio, break it up into 30-second chunks, create hits for each one. They've already pre-qualified a set of people that are really good at transcription. They take those audio segments, they throw them out, wait for all the results to come back, combine them, adjust all the boundaries between the 30-second chunks, and they return back to you via email the finished transcription. So in the course of less than 24 hours, I gave them, I did a test. I gave them a 1-hour interview that I'd done with a site called the Web 2.0 Show. Inside of 24 hours, my transcript came back. Was actually pretty amazing. There were 2 little typos in there, fixed those up a little bit, took them, cleaned them up, put it on the web services blog so more people could kind of could read what I'd been talking about. Pretty amazing service. So they didn't have to employ anybody. They probably have no physical facility other than a couple PCs in their house, and they're able to offer this just amazing service.
Just out of curiosity, why chunk it at 30 seconds? It seems less efficient.
Apparently it was better to have people do small pieces than to try to listen to the entire thing as one real big block.
I would disagree with that. I'm a big user. I've been experimenting heavily with transcription services, they're wrong.
Okay, well I think they've done several different experiments, so it might be that they're not chunking them up anymore or that they are. I know that the result they gave me was really, really good. That's the only, so whether they had squirrels do it or people or anything, I have no idea what happened behind the scenes, but the quality of the result was just,
Do it, but they're not in the US.
could be, don't know.
You're saying that the parallelism isn't really good, and that it's the expertise of the transcription beats the parallelism.
Yeah, I just have basically, I have 3 housewives in Manila. They're women who used to work for medical transcription services, and now they have children. So they're just absolutely love to have work at home jobs, and since you can't do PayPal for the Philippines and bank wire transfers are okay for Amazon, but not for me as an individual. I just, Lelaine's brother lives in Miami, and it's just easier. And she actually came to visit. I delivered cash to her once. It was just cool. Why not? Just meet wives and husbands. But we do it person to person, and we found that having skilled people who know your work, especially when you have dropouts, and
They get the context better in that
they
situation.
remove the and that I just said. So I'm getting a much higher level, and quite frankly, I'm paying about the same rate. And I found that
What they did is they actually did some private testing before they put the qualifications on their workers. And I have no idea what they were, but the results so far I've seen I've been very, very happy with.
So there must be some advantage to removing context in the transcription process for what?
Hard to know, really, really hard to know. Whatever it is, it's working well for them. We're watching just the number of things going through the system every day, and they're one of the top requesters right now. Yeah. See, we would also think that those folks in the Philippines, they should be really excited about being potential workers on systems like this, where there's people that have a unique skill. They're maybe not geographically located where they can go off to an office and do it, but that they have something to do that is unique to them. One of the best stories we've seen so far, when we had those block view hits for the first time, I got email from a person, actually I communicated with him on a forum. He had some kind of physical handicap, and wherever he lived, he could not actually go out and get an actual job. And right after we rolled this out, he got on, he started doing all this image processing, and one of those touching stories of he said, I could earn some money. I bought Christmas presents for my family for the first time in 4 years because you guys gave me an actual ability to do something from home that I was able to do. And I was like, wow, this is just,
Living in Arab countries.
yeah, okay.
But basically, in the end, it's another offshoring machine.
Not necessarily. Some of the tasks that are going in there they're not in that will show up in the near future are things like go to this particular address in the city and take a picture of the building that you find there, for example. They're going to have some contextual level of knowledge. There's other hits that say, give us your top 3 coffee houses in Seattle, or the top 3 bowling alleys in Los Angeles. Data collection kinds of things that will need very specific contextual knowledge. There'll be even ways to use qualifications to say, I only want people that are knowledgeable about music because they've bought over 100 CDs from Amazon, let's say. So there's going to be a lot of different ways yes, there'll be an offshoring component to this, but there will also be a lot of things that you need some very domain-specific or location-specific knowledge to properly do.
It's an enabling technology. You can
Yeah.
use it for
Yeah, we are looking forward to just any number of different, totally shocking, surprising kinds of things to show up in here.
Is there a way for the certification process to be made more specific, for an individual requester? So that, for example, rather than a simple, yes, no, a multiple choice test, that it actually be tied to some national certification?
We're actually working on that. We want to be able to do things like you have a particular kind of degree from an institution and have a way to verify that, or it could be a thing like an SAT score or a GRE score or any kind of real world test. We're ultimately going to have a way to tie that in as well. So right now, the more clever requesters that need to do that, they're doing some kind of offline kind of a thing, where you need to prove your qualification to them offline, and then they'll use the APIs to put that qualification on you. One of them was you need to prove you were in the IT business. And the way that they did that is they said, you need to actually send us a scanned copy of your business card. And they would then look and say, okay, this is some known entity. We can go do some offline checking. We can prove the identity of this person, and they'll give you that qualification.
So there can be a dialogue between the requester and the candidate?
Yes, the requester actually has the ability to send emails to the worker. So this is still in beta, and we do anticipate lots and lots of interesting new ways to use it, and probably new APIs as well. But pretty cool stuff for the last couple of months that it's been.
Important, like when you're using it to capture a quantity, for instance.
We never know what's going to show up.
Would you do that?
There's a lot of statements in the agreement of what it can and can't be used for, and that you've certainly got to go for local rules and customs and so forth. So, don't know. Yeah, don't know. We're the one with the beard was totally surprising to us. It was a guy on our own floor said, hey, I want to just give this a shot and see. We'll let the audience tell us. So that kind of get us to the next thing. Is okay, why don't we choose pants and a shirt from the Amazon catalog and make a hit that says, does this shirt go with these pants, for example? Would be a fascinating kind of a hit to do. It turns out people have opinions. They're always happy to share their opinions, and you aggregate enough of them, then you get interesting information back out of them. So as the final step in the transcript, I just get an email, comes back with my whole text of my podcast. It was very, very neat to do that. And they showed it to me in HTML as well. And there it was. So finally, getting started. Pretty easy to get started with our various services. We have a developer portal at aws.amazon.com. The Mechanical Turk is at mturk.com. And then we have our web services blog is at aws.typepad.com. I can put these all up on a server somewhere if you'd like the URLs, or I can email them to you, or whatever you'd like. So that's about all that I have to say. I'll be happy to answer some more questions and be around afterward as well. Question in the back there?
Yeah, is Amazon moving to selling like online content? Like iTunes or like Google Media?
So we've done a fair amount with ebooks, and looks like there's a lot more that we can do in that direction. As far as other kinds of content, there's nothing specific I'm aware of, but I generally don't know about things until they happen because I'm out speaking in public so often. I generally wait until we're just about ready to release things before I know a lot about them. So that way I don't accidentally talk about things that are future things rather than current kinds of things. But the ebooks certainly seem to be doing pretty well for us. I know we're working with a lot of vendors to get more ebook kind of content into the system.
You're talking about product as the thing that's being, that you're creating a market for your own your own catalog. Can there be more restricted catalogs that are only visible to authorized users? Or?
There are ways to do that. So we have some merchants that put things into our catalog. Like if you are Nordstrom's puts a lot of things into our catalog, and they're visible only in the scope of our own catalog. They're not visible to web services, which is slightly different than what you're asking for. But we do have some ways to restrict access. Like companies like Nordstrom and I think The Gap, they don't like their products being kind of leaked out through web services because they like a lot of control of context and presentation. So they're like, we need to protect the brand. We need to make sure these things don't show up in unusual sites or unusual situations. So they've said, don't let our products participate in web services. Now, we could go a step further than that and say, the only thing you want to use Amazon for is essentially the data repository of information about your products. I think we have the technical way to do that. I don't think we really encourage vendors to do that because there's not a whole lot of benefit for us in doing that and just being the database, really.
And talking about product, that product can be, physical items that actually get shipped through your shipping mechanism or delivered via electronic delivery.
Right, because you can do electronic delivery. There's a thing called a digital locker that's associated with your account where you can download content. I think you can get movies, you can get ebooks, a couple other kinds of things electronically.
But it seems like you could also use it for things, for example, for HOSEF, an organization that has membership. Amazon could act as the market
Potentially.
that allows people to come in and pay for their HOSEF membership using PayPal, credit card, whatever.
But couldn't you just do that with the HOSEF site and the PayPal button? Why add another?
Probably could right now.
I'm sitting and I'm listening, thinking heavily because I'm pretty much fired. There's a fair amount of bad blood about, I'm what they call an author, a little piece of trash that sits down underneath Amazon and the publisher and actually writes the books and gets less money in sale of each copy than Amazon. That's far less. So, but we'll talk about that during my presentation. A question about how to do this. I'm working with Bob on it. We're trying to move this on, and I'm actually wondering. I've killed my Amazon affiliate thing, so I'm direct here from affiliate. So I get, instead of 8 cents a copy from Amazon, I get $4.50.
Because you're going direct.
Kind of small, plus my $2.10 average royalty, so I get twice as much money as selling books as writing them, which tells me where that's stacked. So we have to, my next thing is, starting at the end of this month, I'm working to change this system, and it may or may not affect Amazon's business. I mean, it's interesting enough, my books do not sell well on Amazon. They sell like gangbusters to Prentice Hall site and to Barnes and Noble and other chain bookstores physically. I do not, well, actually I do know Prentice Hall.
Interesting. All right, you're going to talk about that later today?
Yeah, we'll talk about
All right, I'll look forward to hearing that.
it. We need to eat first.
Okay. Sounds good to me. Any more questions? Great. Well, thank you very much.
Hey, important question, where are we eating?
That's not mine to answer, but here's how you can find me. jbar@amazon.com, or you can Google for me, or you can just hit the blog and you can send us email through there.